Hello everyone. This is the next video number 6 on the series of physics lectures on kinematics. In this, we will talk about one-dimensional motion, the equations of motion. Let's proceed. Here is another question to solve based on the basic definitions. Here, the acceleration as a function of time is given to us. We need to solve it to find the displacement of the particle at t equal to 3. So solution will be of this sort. This acceleration can be written as dv by dt, which is equal to 2t plus 1. Now if we rewrite this equation, so it will become dv is equal to 2t plus 1 dt, and we can go for the integration both the sides. Initial time is 0, later on time is t. Initial velocity is 2, later on velocity let's say is v. So this will lead to a simplified version or solved version. V minus 2 is equal to t square plus t. So from here the velocity at any moment of time can be given as t square plus 2t. Sorry, it's a t square plus t plus 2. Now using this velocity we can find the displacement. So velocity can be written as dx by dt, and dt can be taken that side, so it becomes t square plus t plus 2 and dt. Now again we need to integrate it from initial values to final. Initial time is 0, final time let's say t. Initial position is 1, final is x. After simplification this will lead to x minus 1 is equal to, right hand side will become t cube by 3 plus t square by 2 plus 2t. Now this is the position as a function of time. We need to find the position at t equal to 3 seconds. So when t equal to 3, if we substitute it in this, x will come up as 1 plus 3 ka cube divided by 3 plus 3 square, which is 9 by 2 plus 2 into 3. Simplifying this, we have to get 6 plus 1, that is 7, plus 9 plus 9 by 2. This will lead to 16 plus 9 by 2. 16 plus 9 by 2 will be equal to, 9 by 2 is 4.5, so that's a 20.5. Now so final position of the particle is 20.5. Initial position was 1 meter, so the displacement is final position minus initial position. Final is 20.5, initial was 1, so answer come out to be 19.5 meter. So that's the answer for this part as given in this. Based on the definitions learned so far, definitions like displacement, position, velocity, acceleration and time, we can relate all these quantities. Now in this, to relate these quantities for one dimension motion having constant acceleration, we get few equations. They are known as equations of motion. We consider that our object is located at x equal to 0 when the time was t equal to 0. It got initial velocity u and it will be moving only in the direction of x, and it is being accelerated by acceleration a. Later at time t, when the time becomes t, the position becomes x and the velocity becomes v. So v, x and t are these final values, where these are the initial values. For this, these notations, these equations are true. First equation is v is equal to u plus at, that talks about the final velocity at time t. Second equation talks about the displacement x or s at any time t. This is the combination of first two equations, v square minus u square equal to 2as. And this is a very special equation, this fourth one. In this num quantities is talking about the displacement during nth second, right? If n is equal to 2, that's the second. Equation becomes s nth is equal to u plus a by 2 to n minus 1. These are basic equations. Thank you.